Can you hear me? Are we good? Cool. So I'm Jeff. I work on Flow, this project at Facebook. And for those who aren't familiar with Flow, Flow's moniker is a static type checker for JavaScript. And that's true. Flow is definitely a static type checker, but anyway, it's definitely a static type checker for JavaScript, but that really doesn't capture kind of the core intent and the reason why we're investing so much in Flow. And so that's kind of what my talk is going to be about today. I'll get into that in a second a little more, but right now let's start by talking about tooling in JavaScript. We use it all the time. As long as I can remember working on JavaScript, we've used tooling. As far back as I can remember, we've had various things. If you go back to the days of like Prototype.js and MooTools and all these things, they always would ship a minified build. We've had minifiers for as long as I can remember. And the way that minifiers work is they just look at your code, they decide how they might compress that code, and so that it behaves the same before and after, but the bytes that you send over the wire are smaller. And all this is done with static analysis. There's no running your code, after, if you had to run your code after you ran your minifier, that'd be kind of crazy, right? To make sure that it has the same behavior. So minifiers operate on static analysis. And in more recent times, we've had all these build systems that we've started using, and they've become pretty pervasive in our ecosystem. And build systems themselves are using tools like minifiers, but they themselves are also doing static analysis, right? They're like, you've got Webpack and you've got Browserify, and these things are like scanning your code and reading it and trying to build a dependency graph for your entire project so they can build a package, stuff like that. Then we've got linters, right? More static analysis. We've got these things that are doing stuff like telling you if you have typos in your variables and making sure you put your curly braces on the right line and all that sort of stuff per project. And then, of course, over the last couple of years, we have the rise of the transpilers. These are sort of the epitome of static analysis, right? These things are doing all sorts of things. In fact, a lot of similar things with linters. That's very much intentionally jumbled there, because I know there's a debate about transpilers versus compilers, so I won't preach any opinions on that. But the point is that we have this static analysis happening all over in our tooling ecosystem, and when you really look at these tools, these minifiers, they have really sort of approached an upper bound. Minifiers haven't really gotten that better in the last however many years minifiers have been around, right? Like they've gotten a little better here or there, but ultimately they're basically compressing at the same amount. And if you look into why, it's because the amount of analysis they would have to do an even better job is pretty tricky. There's a lot of information that's just generally difficult to do with JavaScript, so they tend not to even try. Well, about 3 years ago, there was a group of people at Facebook that built this library that you probably haven't heard of called React. And it was a really interesting project, and everybody inside the company became really excited about it, and it spread like wildfire. Now, as somebody who was sitting on the JavaScript infrastructure team at Facebook at the time, this was really exciting because lots of people were becoming more and more interested in JavaScript in the company. But it was terrifying at the same time because we kind of had a lame sort of setup with regard to managing such a large code base. So for it to become even bigger was, it was kind of daunting. We had all these like weird sort of conventions that we would use that ultimately boiled down to make sure that all of the code you write in JavaScript is greppable, because that's kind of the only tool we can really use to trace things through the program if we want to do refactoring or changes to our code base, or if we wanted to like search for the definition of a function, stuff like this. Well, now that React is like sort of spreading JavaScript everywhere in Facebook and outside, we really had to sit down and rethink this approach and think about how can we build tools to automatically understand our code base and do more interesting things and make the dev experience better. So this is where the project flow came out of. And in the beginning, before we went off and decided we were going to build a new project, a new tool, we kind of looked around and wanted to see what things were already available. So the first thing we looked at was obviously Closure Compiler, right? Closure Compiler is like the Pied Piper of JavaScript minifiers, right? Like I mentioned that like minifiers haven't gotten better over the years, but this is the total counterexample to that. Closure does an extremely good job in advanced mode to taking really large JavaScript applications and shrinking them down as small as feasibly possible. But the problem is that it does it with a big trade-off. You have to write your code very carefully if you want to use Clojure Compiler Advanced Mode. And you have to do things that aren't necessarily natural in JavaScript. Like, you kind of have to put sort of JS docs on a lot of your stuff to get some of the advantages out of advanced mode. Or if you have properties that you don't want Clojure to minify, you have to put it in brackets, right? And make sure that you put it in quotes. Otherwise, if you happen to forget to do that, Clojure is going to minify your code, and that whole trait of minifiers that makes them worth what they're doing is gone, and the output of the minifier, the output of Clojure, is broken code, simply because you forgot this one constraint. So this was a deal breaker for us, especially because if you forget one of these sort of rules on accident, all of a sudden your code is broken and you just had no warning. It doesn't tell you, right? It doesn't know. Another tool that we looked at was TypeScript. TypeScript is much closer to what we wanted in terms of like building intelligence around our code base. And it's a very good tool. If you look into TypeScript, what you see is you have this sort of more of an intent-based, this idea of putting type annotations into your code, and by using those type annotations and enforcing them, you can extract information out of your code. This is awesome. But one of the issues that we ran into with TypeScript is that it's very much focused on that sort of explicit constraint-based approach to code intelligence. What we really wanted is to be able to take JavaScript and do as much as we possibly can without developers having to change the way they're already writing code in order to pull intelligence out of the code base. So this is the main goal of Flow. When I said earlier that the goal of Flow isn't necessarily to be a type checker, what I meant is Flow is really about being a code intelligence engine. We want Flow to be able to be a platform for other tools like minifiers and code optimizers and linters to do more interesting things, to get past that barrier of complicated static analysis that's there. And so Flow is very much powered, the Flow, the tool, is very much powered to do this. Now today, if you go download Flow, you're going to mostly get a type checker. It's going to give you type errors. And the reason for this is because types are a really important and pretty difficult basis for code intelligence. This is the first big problem we're solving with Flow. So to kind of illustrate the type system in Flow, I'm going to show you some code examples. Now here we have a function. Hopefully that's readable. It computes the area of a circle given its radius, right? And you'll see at the bottom, we're calling this function with a string. Now, I'm curious if anybody in the audience knows what happens if I would run this code. Does anybody know? We have nan. What else do we have? Okay. So what will happen when you run this code is you're going to pass that string into this function. It's going to go to that multiplication operation. And JavaScript, because it's JavaScript, is going to try to convert the input, because it's a string, because it doesn't make sense to multiply a string, is you're going to try to convert it to a number. Now, if you had a string of 10, you're going to convert that string to the number 10, and everything is going to chug along and work just fine. But the person who said nan may already know this. For those who didn't know this, I probably tricked you here. That's not actually a 0, that's an O. And so this is going to actually produce nan, so you're right. And this program is actually not going to work probably like you expect it to. So if we take this code and we run it through Flow, all we have to do to get information out of Flow is add this little comment at the top, this @Flow comment. And the purpose of this @Flow comment is to tell Flow that you're now interested in what Flow thinks about this code. So Flow is a gradual type system. You don't adopt your whole code base all at once necessarily. This is important because it's nice to be able to iterate without a type system kind of bugging you along the way. It's useful when you're prototyping, for example, to break parts of your system and sort of get them working, and then at the end, kind of get everything back together again. So we're ready to sort of move forward with this code, so we add our comment at the top. And as you might expect, it's going to tell us that we have an incompatible type here. Flow is going to give you this error message. Now you'll notice we didn't do anything to this code. It's just regular old JavaScript. We didn't do anything to this code, no type annotations. All we did was add that comment to the top. This is pretty cool, and this is what I mean by we really truly want to understand the code base. We're not out to sort of change the way that developers write code. And I'll be honest with you, that's going to be necessary sometimes. Sometimes, JavaScript is a huge bag of pointers, and you just need some help. But for the simplest cases, you shouldn't really need to do anything else. Interestingly, if you run code like this a lot of other type systems don't go this extra mile. So a lot of systems like Java and C++ and TypeScript and Clojure compiler, if you were to run this code through it, it would not give you a type error. So let's move to another example. Here we have another function that takes an input variable, and you'll see that we're passing in a null value for that input variable, but inside the function we're calling a length property. So in this contrived example, it's super obvious there's a bug here, and there's no way this will work. But you could totally imagine having a null value coming from somewhere else in your system 10 files away. But so anyway, and here, what we're doing is we clearly have a bug, and as you might expect, if we run this through Flow, you're going to get an error. It's going to help you catch this quicker. And the important bit here is that many type systems model null as what's called a bottom type. And this means the bottom type is the type that has no possible values. Well, a type that has no values sounds like a subtype of all other types, right? If the definition of a type is the set of possible values that a variable can have, then no values is certainly a subtype of some values, right? So this is the approach that a lot of type systems take, Java, C++, Clojure compiler, TypeScript. But this wasn't good enough for us because it's something that people use in JavaScript all the time. People use null. You've heard the billion-dollar mistake quote before probably about how null is just a horrible idea. And the truth is, null is not necessarily the horrible idea. It's the mistakes you make when you use null. You lose track of it easily. So having a tool that can track it and tell you when you've messed up is really useful. So the question, of course, when you have a situation like that, if you had a real bug like that, and let's say you found it in production, you didn't have Flow, anything, doesn't matter how you found the bug, you need to fix it. Well, the way you'd fix it is you'd either not pass null into the function, or you just make it so the function itself can accept null values safely. So I've chosen the latter here, either would work. And in this case, we're just checking to see if input is null, and we're also sort of being a little conservative here and saying it's not null, and it's also not undefined, hence the single equals. Hopefully that doesn't irk too many people. And then when we add this fix to our code base, Flow doesn't give us an error anymore. But more importantly, it's not that Flow just isn't giving us an error. Flow actually understands what's going on. It understands that this code is now safe. We didn't just confuse Flow. So in the if block right here, where we return input.length, Flow actually understands the type of input is something with a length property. And it's definitely not null. It understands that by reading the conditional, just like you as human beings would understand this. And it also understands that in the else block, Flow is absolutely, definitely either null or undefined. So that means if you use it, and we're not in this example, but if you use the input variable in the else block here, in any way that's not compatible with null or undefined, if you try to call a property on it, if you try to pass it to a function that can't take null or undefined, Flow will know that you have an unsafe bit of code, and it will give you an error. So you can catch all this stuff very quickly. Now, I've been showing you a bunch of examples so far that are just like raw JavaScript, and there's like no additions except that comment at the top. But the truth is, sometimes type annotations are actually useful. And there's a couple reasons why you might actually want to add type annotations, and Flow does support this. So here we've added some annotations to our function, and the way this reads, if you're not familiar with the syntax, is you can read colon as has the type, and question mark is nullable. And so we'd say the input parameter has the type nullable string, and the colon at the end is the type for the return type of the function, so return type has the type number. And this is a syntax that TypeScript kind of built. We've tweaked it a little bit for some features that are specific to Flow, like nullability. But ultimately, it's useful to be able to specify this because readers of your code base, if any of you have worked in a type language before, it's pretty useful sometimes to go and look at the definition of a function. And a lot of times you can just grok the type interface and get all the information you need on how to use that thing. Without type information, this function is pretty trivial, so it's not much work. But if we had a really long function and you had a type annotation here, it would save you from having to figure out what exactly you mean by input. Right? Perhaps it's a bad name, but when you have long functions, you're not really sure. You want to go read the implementation. Here we see, oh, it clearly can take null or string, so that's why I'm going to pass to it. There's actually another reason why type annotations are useful in this example. Not only is this good for documentation, but it actually clarifies to Flow what the intent is for this function. The implementation we had before the type annotations would take any object that has a length property, any object at all. Because Flow is running inference, and it knows that technically that would work. It doesn't really know your intentions, but it knows that it would work. But here we're saying it won't take just any object with a length property. We're saying it really needs to be a string. So this is a way for you to communicate to Flow, in addition to other people, and tell it, this isn't just any old object. This has to be a string. Can't be a class with a length method. None of that stuff. It has to be a string. So let's look at a slightly less contrived example. This is a neat feature of Flow that we added recently. And it was a feature that actually a couple of people were asking for, or they were running into while using Flow. GraphQL team, I think, was actually one of the people who was requesting this pattern. What we have here is a function that will sum the leaves of a binary tree. And the way this binary tree is structured is you have one of two objects that might go into this function. You have a leaf object, which has a value property, and you have a branch object, which will have a left and a right property. And so given that this function will take two different types, we need to sort of disambiguate between these two types, and so we use a switch statement on a kind property that's sitting on this object. Well, if you just run this code through Flow, it's not going to be very helpful here. And the reason is because it doesn't really understand, it can't really automatically infer that you have two different kinds of objects here. So this is where you actually do need to help Flow out a little bit more. Now, prior to when we added support for this, there wasn't really a good way to make this work. But fortunately, we added something to Flow called disjoint unions. And this is a neat idea that comes from a lot of functional languages. And basically, what we're doing here is, this is another bit of extended syntax, a bit of extended grammar for JavaScript. And what we're doing here is we're defining a new type called binary tree. And this tells Flow that we have a union type. So we have either a leaf object or a branch object. And a leaf object, these are type annotations, by the way, if that's not obvious for people who aren't familiar. They're not actually object literals. So the leaf object has a kind property and a value property. The branch has left and right and kind. And another thing you'll notice, and this isn't a typo, is that while we typed the value property on a leaf as number, we typed the kind as a string literal leaf. You might have expected that to be specified as string, but very intentionally, this is typed as something called a singleton type. Now, if you remember what I said earlier about the way, like, singleton type is sort of, if you haven't heard of it before, it might be a little cryptic, but it actually makes a lot of sense. The definition for a type in a programming language is the set of possible values, right, that can go into a variable. Well, a singleton type is a set of one. So a singleton type is just a fancy way of saying this will always have that value. And this informs Flow all of the information that it needs to be able to understand the sumLeaves function by just annotating this tree input parameter as a binary tree. Flow now understands that, similar to what we had before with null, inside that case branch, Flow understands that tree is definitely a leaf property. So if you try to access left or right accidentally, Flow can give you an error. And in the default property here, Flow understands that, well, we have two types in our union, so it's anything left. Well, we only have one left, so it must be a branch. Like this is sort of the process that Flow goes through as it's making this decision. So therefore, it definitely must be a branch object, and it has a left or a right property. And if you try to call value, say on accident, or something else, Flow can give you an error. So this is pretty cool. You can imagine circumstances in, if any of you have ever played with any of the transpilers like Babel or Tracer, where you want to sort of run through a syntax tree, this is a very common pattern. This is also a very common pattern in Flux, right? You have a big switch statement with actions and dispatchers, or stores and dispatchers on action objects. So yeah, I think this is a pretty cool idea. I was pretty excited when we added this. So the future of Flow, we're kind of in the early days of Flow. We open sourced it about a year ago, and it's continually gotten better. The feedback remains to be positive, which is always uplifting. But like I said, the real goal of Flow is to be a code intelligence engine. So we want to be a platform for other tools. So if you go and download Flow right now and run flow-version, you're going to see a list, or sorry, flow-help. You're going to see a list of various commands you can call to pull information out of Flow about your code base. It's not just a type checker. You can do things like find the type of a variable at a position, if that's useful to your tool. You can do things like find the definition for a variable at some random position. And that can be multiple modules away. This is the purpose of Flow. So given all these ideas, we're really excited to see some people sort of build on top of this. Some cool things you might be able to do, and we actually definitely hope to see happen soon, are optimizing compilers. We should be able to do a lot of the things that Clojure compiler is doing and give up when we're not sure. Rather than pushing the burden onto developers, let's just optimize where we can. And maybe we can suggest to users things they could be doing differently. Editor integrations, autocomplete, right? Refactoring tools. If I have a class and it has a get method on it, there's probably 1,000 other objects in my entire code base that I'm calling obj.get on. So if I want to use grep and try and rename that method, well, good luck, right? But if we have a type system, we understand that the type of this class corresponds to the type of some of those objects. And if we can link those objects back to that class, we can refactor the name get to get foo or whatever. So editor integration is pretty cool. Deeper refactoring tools, the ability to do what we call code mods is something that we're pretty excited about. People are actually already working on this. And then something we're not really thinking too much about, but it's a cool idea, I think, is anybody who works in security, I think, if you're interested in this, I think it'd be pretty neat. Flow is doing data and control flow analysis already, so there's probably all sorts of opportunities that we could be leveraging out of the information that Flow is gathering for things like taint analysis or various other kinds of security analysis on code bases. So that's pretty much it. Flow is open source. You can go download it. It ships out of the box with support for React and JSX. So you can use React.create class if you have legacy stuff. You can use extends React.component. Extends is going to give you a little more flexibility with Flow because you can statically type your props and your state, which is pretty cool. You can do a little bit of that with React.create class, but it's kind of limited. Check out the Twitter. We always announce when we do new features, and most of the team hangs out in the IRC channel. So if you're interested in asking questions or whatever, hop in there and chat. Thanks for listening.